Look at the outlet on your wall. Not a glance. Actually, look at it. Two vertical slots, one slightly taller than the other. A small round hole sitting just below them in the center. It looks like a face, a surprised little face staring at you from the wall, and once you see it, you cannot unsee it. Most people notice this once as a child and then forget it forever. They spend the rest of their lives walking past hundreds of these faces every single day and never once asking the obvious question. Why does it look like that? Not just the face shape, the specific details. Why are the two slots different sizes? Why is the round hole there at all? Why is it round when everything else is rectangular? None of it is accidental. Every millimeter of that design was shaped by disaster, by death, by decades of engineers trying to solve a problem that electricity kept creating in the homes of ordinary Americans. When electricity first entered American homes in the 1880s, it arrived without rules. Thomas Edison was laying copper wire under the streets of Manhattan. George Westinghouse was pushing his own system. Two brilliant men in a war over whose technology would power the country. The first home wiring was cloth over copper, sometimes rubber that dried and cracked within a few years. Wires ran through wooden walls with nothing protecting them. No standardization, no inspection, no national code. No standardization, no inspection, no national code. A home in Boston was wired completely differently from a home in Chicago, and both of them were held together with methods that an engineer today would refuse to touch. People died. Houses burned through the night. And for a decade or more, the official response was essentially that electricity was new and dangerous, and some amount of loss was the cost of progress. That thinking ended the moment it became clear the losses were not slowing down. They were growing. That thinking ended the moment it became clear the losses were not slowing down. They were growing. The first attempt at a solution was the two-slot outlet, simple, clean, just two openings in the wall. But even inside that simplicity, engineers made a choice most people never notice. Look closely at those two slots. One is taller, one is shorter. They are not the same size. The taller slot on the left is neutral. It carries current back from the appliance to the panel. In a healthy circuit, it sits near 0 volts, technically alive but practically harmless. The shorter slot on the right is hot. 120 volts of live alternating current flowing from the panel outward, constantly, whether anything is plugged in or not. Making the slots different sizes was called polarization. A plug built to match can only go in one way, hot to hot, neutral to neutral, every time. This mattered because of how lamps were built. A properly polarized lamp socket carries the hot current only to the small center contact at the very bottom of the bulb cavity. The wide metal ring around it stays neutral. Touch that ring while changing a bulb and nothing happens. Wire it backwards and that ring is live. People went to change bulbs and did not come back. Polarization was invisible engineering. It asked nothing from the user. It just worked quietly inside the object and kept people from completing a circuit through their hands. For a while, it was enough. Then the appliances got bigger. For a while, it was enough. Then the appliances got bigger. Refrigerators arrived, washing machines, heavy equipment with metal bodies that people gripped with both hands. Inside an appliance, a wire works loose over time. A small crack in the insulation. A manufacturing defect invisible to the eye. It happens slowly. The appliance still works. Nobody notices. And the metal body of the appliance quietly becomes energized. And the metal body of the appliance quietly becomes energized. Not from any mistake the user made. Just from time and use and the ordinary physics of electricity finding new paths. In a two-slot system, that charge had nowhere to go. It sat on the casing and waited. A woman reaches for her washing machine while standing on a damp concrete floor. Her hand touches the metal panel. The current that has been building up inside the machine finds what it has been waiting for. A path to ground. Through her. This was not rare. It was happening in homes across the country, in garages, in laundry rooms, in kitchens. And the electrical code had no answer for it because the problem lived inside the appliance. The answer was the third hole, a ground wire, a copper conductor running from every metal appliance casing back through the wall, back through the panel, and down into a copper rod buried in the earth outside the building. The physics are simple and devastating in their elegance. Electricity always takes the path of least resistance. If a fault develops inside an appliance and the casing becomes charged, the ground wire offers that charge an easier path than a human body. Current flows into the wire, into the earth. The circuit breaker detects the imbalance and trips. The appliance goes dead. Nobody gets hurt. The round hole at the bottom of your outlet is the entry point for that wire. The moment you push a grounded plug into the wall, that round blade connects first, before either of the flat blades make contact. And when you pull the plug out, it disconnects last. Ground connects first. Ground leaves last. This sequencing is not written in a manual somewhere. It is built into the physical geometry of the object. The round hole is positioned lower than the two slots precisely, so the ground blade has to travel slightly further to engage and disengage. Safety embedded in shape. The National Electrical Code made grounded outlets mandatory in new construction in 1962. Before that year, homes were built without them by design. Millions of older American homes still have the two-slot version behind their switch plates. Those outlets are not broken. They are simply from a time before the engineering caught up with the problem. So look at that outlet one more time. The unequal slots. One decision made after too many people touched live lamp sockets. The round hole. One decision made after too many people grabbed the wrong appliance on the wrong floor on the wrong day. And the surprised expression the whole thing creates, that comes from the ground hole being placed below center, not for aesthetics, because the lower position is what allows the ground blade to connect before the live blades do. Nobody designed a face. They designed a sequence, and the face was what the sequence looked like when it was finished. What is staring back at you from your wall is not a piece of hardware. It is a record. A record of every problem electricity created and every solution engineers fought for. It was never decorating your wall, it was always protecting it.